Hello everyone. Today's lecture is on nonlinear pricing. In particular, we are going to focus on quantity discount. First, what is nonlinear pricing? Let me give you an example to compare nonlinear pricing to some of the other ways of pricing. On the horizontal axis, we have the quantity to the customer. On the y-axis, we have the total cost to the customer. Note that we are not looking at a demand curve. So this is not demand. This is the total cost to the customer. First, if we have a fixed fee, then the total cost to the customer does not change with the quantity. So an example like this would be Netflix. They charge a monthly subscription fee and you can watch as many movies as you want. The second type of pricing is what we call a linear pricing. As you can see, in a linear pricing, the total cost to the customer increases linearly proportionally with the quantity purchased. The more you purchase, the higher the cost. So linear pricing is what we are most familiar with in everyday life. You buy one Big Mac, it's $5. You buy two, it's $10. You buy three, it's $15. So that's linear pricing. So what we are looking at today is when this relationship no longer goes a straight line. Here is one form of nonlinear pricing. It's called quantity discount. As you can see that here the price has three segments. In the first segment, the price increases with quantity, then it increases with quantity slower, then it increases with quantity even slower. That is, the more you buy, the lower the price is. This is what we call a quantity discount. In addition, there are some other forms of nonlinear pricing. This is what we call a two-part tariff. In a two-part tariff, there is a fixed fee. So even when quantity is zero, the total cost does not start from zero, and then it starts to increase. Two-part tariff is basically a fixed fee plus a linear pricing segment. An example like this could be some kind of retail price club. You get a Costco membership, it costs you a fixed fee, and in addition, you pay the prices of the products you buy. And here's another example of what we call a three-part pricing. Here, in the blue line, the fixed cost goes on for a while. Then, when you purchase more, the unit cost starts to kick in. So in this scenario, the fixed cost you pay covers certain expenses. But if you do more, you're going to pay more. So this is a typical golf club type of pricing. So you pay a membership fee, it covers one round of golf a month. And beyond that, you have to pay on a per usage basis. So here are basically different types of nonlinear pricing. The focus today is on a particular type of nonlinear pricing. It's called quantity discount. If we examine two-part tariff, it will be in a separate lecture. First, what is a quantity discount? And why running quantity discounts? So the reason why companies very often offer quantity discount is this is true for consumer markets and business markets, that customers often value each additional unit differently. For example, let's say you go into a restaurant, you buy mini burgers, and when you are hungry, the first burger tastes really, really good. And the second one, still pretty good, but you're not as hungry. And the third one, even less so. Customers often value each additional unit of the product differently. When they buy more or when they consume more, they tend to have lower valuation in additional quantity that they purchase. So this is why it might make sense to offer quantity discount in the market. In this example, we look at cinema visits. Someone can visit the movie theater once, twice, 3 times, or 4 times in a month. The willingness to pay per customer per visit for segment A is $11 for the first visit, $8 for the second, $5 for the third, $2 for the fourth. So that is, in the usual months, you may have one movie that you really want to see, and when you visit the theater more often, you start to see the movies that you are less interested, so your willingness to pay goes down. So in this example, we have 3 segments: segment A, segment B, and segment C. And the willingness to pay information are identical for all the three segments. Again, customers are willing to pay more for the first visit, then the second one, then the third one, then the fourth one. So the dollar values are 11, 8, 5, and 2. Now let me introduce a second market structure where again we have three segments, A, B, and C. The difference is now the three segments have different numbers in their willingness to pay. Although within each segment, their first cinema visit willingness to pay is higher than the second, third, and fourth. First higher than the second, third, and fourth. First higher than the second, third, and fourth. But these three segments have different distributions of willingness to pay. So the reason why we use these two tables is we want to see whether it makes any difference if the market is relatively homogeneous. So all three segments are the same, or the market is more heterogeneous when different segments have different willingness to pay. One key thing to note in these two examples is that the average willingness to pay for the first table and the second table is the same across the three segments. So in the first case, the average is 11, 8, 5, and 2 because it's all the same. In the second case, the averages are again 11, 8, 5, and 2. One lower, one higher. So these two different market structures on average have the same willingness to pay distributions. And as a reminder, you can actually draw a demand curve based on these willingness to pays. For example, if we want to draw the willingness to pay for customer B, then we know that at the price of $11, the customer would buy one ticket, and at the price of $8, the customer would visit the theater twice, at $5, three times, and at $2, the fourth time. And if we put all these customers together, we can actually draw a demand curve of this market. Since we have done this exercise when we did willingness to pay, I'm not going to repeat it here. First, let's look at what if we charge a single price. In this case, we use the same price whether the customer visits the theater the first time, the second time, third time, or the fourth time in a month. So we charge a price P1 for any ticket purchased. And in the second market structure, we charge a single price P2. Now let's look at these two different cases. On the top right corner of the screen, I've shown the willingness to pay table so that making our calculations easier. In a single price case, we assume customers purchase if the price is less than or equal to the willingness to pay for that unit. And assuming the cost for the movie theater is zero, both for simplicity and also the cost per person in movie theaters is pretty low. If we don't leave any money on the table, this means there are only four feasible price levels based on the table: $11, $8, $5, and $2. So if we charge any dollar amount in between these willingness to pay levels, we'd be leaving money on the table. For example, charging $10 would make no sense because we can raise the price to $11 without losing demand. So we would never charge between willingness to pays. We always charge at the willingness to pay numbers. So the feasible prices are 11, 8, 5, and 2. We'll look at how the demand changes at these four different price levels. So for each price level, we calculate the unit sales and the profits. Again, when we refer to sales in this class, we are always talking about unit sales, not dollar sales. As you can see in this table, first, when we charge $11, the total tickets sold is 3. That is because customers A, B, and C, their willingness to pay is 11 for the first ticket. So each of them would visit the cinema once. So here we have 11 times the demand of 3 for the 3 customers. That's equal to $33. That's the total profit. Again, since we don't consider cost, the profit is equal to the revenue. Second, we consider if we charge the price of $8. So when we charge $8, we have 1, 2, 3, 4, 5, 6. So 6 units of cinema visits have willingness to pay at $8 or above. So the total quantity of sales is 6, and 6 times $8 is 48. So each customer buys 2 units. And then similarly, we can calculate at $5. The total quantity is 9, and 5 times 9 is 45. So each customer buys 3 units. You can try $2 yourself. So then, after we calculate all these profits, we're going to compare which one gives us the highest profit. So in this case, the highest profit is $48, and the optimal price that gives us the highest profit is $8. Next, let's look at a single price when segments A, B, and C have different distributions of willingness to pay numbers. In this case, we have many more willingness to pay levels. So each willingness to pay level is a potential price level to charge. Therefore, we have 12 feasible price levels from $12, $11, and all the way to $1. Again, for each price level above, we compute the unit sales and the profits. So in this table, we have the price at $12, the quantity of demand is 1. Only customer C would buy 1 ticket, and the profit is 12 times 1 equals 12. And then if we drop the price to $11, now we have a demand of 2 because customers B and C both have willingness to pay above 11. So quantity of 2 multiplied into 11, we have a profit of $22. Customers B and C both buy 1 unit. And then similarly so on and on, we can calculate the price levels of 10, 9, 8, all the way to 1. And then we figure out the demand based on the willingness to pay table. Then we can calculate the profit received. You can try it yourself to sort out all the different price levels. And after this calculation, here is a summary of what we have in the single optimal price case. So for the case where everybody is the same, the optimal price is $8 and the profit is $48. And in the case where the customers are different, although on average the same as the table above, the optimal price is $7 or $6. They gave us the same profit levels of $42. $48, $42. As you can see, in the market where the customers are the same, the company actually can get higher profit than when customers are different from each other. To show you visually how single price versus quantity discount works, again, we're looking at quantity versus total cost to the customer. In a linear pricing scheme, we have one price, P1, and the total cost increase linearly with the quantity of purchase. And then in a quantity discount, which we'll discuss next, what we have is the customer is charged one price at P11 for the first 2 units purchased, and then anything above the 2 units, we charge a lower price, P12. So this is basically a quantity discount. And the way this is implemented in the real market is, for example, coffee shops sometimes offer stamp tickets. It will record how many number of cups a customer has purchased over a period of time. So the quantity a customer has purchased during a period of time is relatively straightforward to track. So here we are looking at a 2-block quantity discount. We charge a price P11 for the first and second cinema visits, and then P12 for the third and fourth. Similarly, we charge P21 for the first 2 visits and P22 for the third and fourth visits. So for the first 2 units, as we can see here, the customer's willingness to pay are $11 and $8. So P11 has 2 possible levels, 11 or 8. Given what I've calculated before, we know that at $8, it will induce each customer to buy 2 units, and the profits are $8 times 6 tickets sold. That's $48. So what about P12? So for P12, there are two possibilities, either $5 or $2. And if we consider the additional units sold at P12 equals $5, we're selling 3 additional tickets here. So 5 times 3 equals 15 because these 3 will not buy at $5, so they drop out of the markets. If we drop the price to $2, then the quantity becomes 6. All 3 customers would buy the third and fourth ticket, and now you have 2 times the demand of 6 equals 12. Comparing these two, 15 is larger than 12. So the best thing to do is to choose P12 equals 5. To summarize, we charge $8 for the first 2 visits and $5 for the third and fourth visits. And the total profits are 48 plus 15 equals $63. Now the quantity discount calculation when the segments are different. So for the first 2 visits, we charge $7 to induce each customer to buy at least 2 units. So the profits are 7 times 6 is 42. And again, you can compare possible price levels of 12, 11, 10, 9, 8, and 7. Ultimately, 7 is the price that gives you the highest profit at $42. Next, we look at P22. So for P22, there are 6 possibilities, 6, 5, 4, 3, 2, and 1. And we are going to calculate the profit at each price level to figure out which one gives us the highest profit. For example, when P22 equals 6, the additional demand is 1 additional visit from customer C's third visit. And then the additional profit is $6. If we charge $5 for the third and fourth visits, the quantity of demand is 2. The additional profit is 2 times 5, that is $10. You can try all these calculations yourself, and ultimately you compare the profit at these price levels, and we'll figure out the optimal P22 is either $3 or $4. So let me summarize the quantity discount with 2 price levels. So when customers are all the same, we charge $8 for the first 2 visits, $5 for the third and fourth visits, and the total profit is $63. When customers are different, we charge $7 for the first 2 visits, $4 or $3 for the third and fourth visits, and then the total profit is $54. If you remember the profits we got earlier, these profits are higher than when we charge a single price. When customers are all the same, the company can get higher profits than when customers are different. Finally, we discuss the extreme scenario of multi-block quantity discount, when we charge 4 different price levels for each one of the visits. So the first visit would have a price of P11, second visit P12, third P13, fourth P14. And similarly, when customers are different, we charge 4 different price levels, P12, P22, P23, and P24. And in the first case, when customers are the same, the optimal prices would be to charge the willingness to pay at each one, since all 3 customers are the same. So P11 equals 11, P12 equals 8, P13 is 5, P14 is 2. And we extract all the possible consumer surplus. That is, we charge at the willingness to pay level of every single visit for every single customer. And each customer would buy 4 units, and the total profit is $78. This is the absolute most amount we can extract from this market. Now, what if the customers are different? The situation is a little bit trickier, so we have to consider each visit differently. So as you can see here, at 10, 11, 12, the optimal price for the first visit would be 10, because 10 times 3 is 30, 11 times 2 is 22, 12 times 1 is 12. So 30 is the highest, $10 is the optimal price. And following similar calculations, we'll get that P21, P22, and P23 are $10, $7, and $4 respectively. And in each one of these cases, the three customers would buy 3 tickets. Now for P24, there are 3 possibilities, $3, $2, and $1. And similarly, we consider if we charge $3, we sell 1 ticket, the additional profit is $3. We charge $2, the additional profit is 2 times 2 is 4. If we charge $1, the additional profit is 1 times 3, it's 3. So 4 wins. And to summarize, what we have is in multi-block optimal pricing, we have 11, 8, 5, and 2 when customers are the same. And the total profit is $78. And we charge $10, $7, $4, and $2. And the total profit is $67. Let me summarize all the calculations we have done so far in one table. So what we see here is, first, quantity discounts can result in higher profits whether customers are the same or different. 48, 63, and 78. The more price levels we charge based on quantity discounts, the higher the profit we get. 42, 54, 67. It's the same. So the second conclusion is comparing across these two conditions is when customers are the same, companies can get higher profits. 48 is higher than 42, 63 higher than 54, 78 higher than 67. I hope with these numbers you are convinced that with quantity discount, firms can actually achieve higher profits. So the question is why this works. The point of using quantity discount is to reduce the pass-up profit on the additional units. If we put it in the demand curve that we have discussed earlier, remember price, demand, demand curve, variable cost, and this triangle corner is what we call the passed-up profit. And this part is where customers' willingness to pay is low. If we charge a price too high above, then these customers are not going to buy. That is, quantity discount allows companies to take care of low willingness to pay demand so that the passed-up profit becomes actual sales and companies can gain additional profit from it. So the idea here is when you've already had one mini burger and the willingness to pay for mini burger has dropped from $4 to $2. If I still charge you $4, you will not get the second one. And by offering quantity discount, you will be able to buy the second one at $2 and the company can gain higher profit from additional unit sales. To recap, we offer the same quantity discount for all customers, but charge a different price for each additional unit. So it's based on quantity, not based on customers. So we don't have to identify who's who. All we need is to identify the quantity they have purchased. And the nonlinear pricing in general has great advantage of self-selection by customers. That is, we don't need to separate who is willing to pay more, who is willing to pay less. Customers who are more or less sensitive to additional demands would decide for themselves whether to purchase the additional units. And the third, I have shown that 4 prices is more profitable than 2 prices than 1 price. The question here is the more complex the nonlinear pricing is, you can earn a higher profit, but it will be more difficult to implement, which means it may be more error prone and customers may not respond to it as well because the pricing scheme has become so complicated. So there is a balance there to strike. That's all for today on quantity discount. Thank you. I'll see you next time.